So in this last part, we're going to look at solving acute triangle problems. With these questions, you may decide to use the primary trig ratios if you have right-angled triangles, or you may choose to use the sine law or cosine law. So example 1. A boat leaves a marina and heads due west for 25 kilometers. Then the boat heads north 30 degrees east for 20 kilometers. How far is the boat from the marina? So first of all, we have to recall our compass directions. So remember, north is straight up, south is down, west is to the left, and east is to the right. So first of all, we're told the boat heads due west for 25 kilometers. Next, it heads north 30 degrees east. So remember, north is pointing up. So let's draw a line going up. So there's north, but it has to go 30 degrees to the east. So east is to the right. So this would be north 30 degrees to the east. And that is for 20 kilometers. How far is the boat from the marina? So what are we looking for is the distance from the start to the finish. So here would be the marina where it started. It headed west and then it went north 30 degrees east. So this is where the boat is now. So we have two sides, so we definitely need to get an angle here. And we're going to use that north 30 degrees east. We can see if we go due west and due north that this is 90 degrees. If 30 degrees is here, then the remainder of 30 from 90 is 60. So that means we have a 60-degree angle right here. So there is the angle that we have for our triangle. So I'm going to remove this part here. I'm going to move the 20 kilometers to the outside of the triangle here. And so we have a triangle with two sides and a contained angle. And we want to find this distance here. We'll call it x. The distance from the marina to the boat. Notice we don't have a known side across a known angle, so we can't use the sine law. We don't know if this is a right angle, so we can't use sine, cosine, or tangent. So for this example, we're going to use the cosine law. And remember, the cosine law looks something like this. A squared equals b squared plus c squared minus 2 bc cosine of angle A. So since we have the 60-degree angle, I'm going to call this angle A to match up with the angle in our equation. And we will call B for the boat, C for the marina, and now we can sub in our values. So this would be little a here, this side would be little b, and this side would be little c. So let's sub in what we know. We know that a is equal to x, so we have x squared equals 25 squared plus 20 squared minus 25 times 20 times cosine of angle A, which is 60 degrees. Next step is to evaluate the right side of this equation, which gives us an x squared value of 525. And if we want to solve for x, we need to square root both sides, and it tells us that the boat is 22.9 kilometers away. So therefore, the boat is approximately 22.9 kilometers from the marina. And there we solved our first problem. So again, for this one, I used the cosine law because I did not have a known side across a known angle, and I also did not have any right angles in the picture. Example 2. A weather balloon is between two tracking stations. The angles of elevation from the two tracking stations are 55 and 68. If the tracking stations are 20 kilometers apart, determine the altitude of the weather balloon. So there are two ways to draw this, but here's one way to solve the problem. So you have two tracking stations. So let's call them A and B. The angle of elevation from one tracking station is 55 degrees to the weather balloon. Let's draw a balloon here. And the second tracking station has an angle of elevation, so the angle that it sees the balloon at from the horizontal is 68 degrees. And we know the tracking stations are 20 kilometers apart. We want to determine the altitude of this weather balloon, how high it is from the ground. So for this one, the best method is determine one of the side lengths, and one of the side lengths of the big triangle. So let's say we pick this one. It doesn't matter. We can pick this one, or we could pick the one over here. So we're going to call the balloon, we're going to give it vertex C, and so let's label this properly. So this would be side A, side B, and this is side C. So at the moment, I'm going to ignore the height, and I'm going to say, well, let's solve for A or B. Let's say we pick side A. Since I'm solving for side A, and I have a known angle across a known side, and you might say, where's the known angle across the known side? Well, across 20 degrees, I can actually figure out this angle here using our 180 rule. And we have that this angle here is 180 minus the sum of 55 plus 68, which gives us an angle of 57 degrees. So we have a known angle across a known side. So this is where we should use the sine law. And we're trying to solve for side A, so let's put A in the numerator. So we have A over sine of A, and our known ratio is C over sine of C. So now let's sub in our values. We have A over sine of 55 is equal to C, which is 20 kilometers, over sine of 57. Next step, let's solve for A by getting rid of the sine 55 from the left side, which means I need to multiply both sides by sine 55. And now I know that A is equal to 20 times sine 55 over sine 57. So let's use our calculators. And we see that A is approximately equal to 19.53 units, or in this case, kilometers. So now we have side A. Side A is approximately 19.53 kilometers. So how does this help us find the altitude? So I'm going to erase part of this triangle now. So we found that angle. We don't need it anymore. We want to find the height or the altitude of this weather balloon. So I'm going to take and focus on this triangle here. Notice there's two right triangles there, but I found the side to one of them. So let's redraw this. So we now have part of a right triangle, which we know the angle is 68, and we know the hypotenuse is 19.53. And what we want to find is the altitude, or the height of this triangle. And since it's a right triangle, we can use one of our trig ratios. Our angle of focus is 68. We know the opposite side and the hypotenuse. So this is opposite 68 degrees. This is the hypotenuse of the right triangle. So that means I can use my sine ratio. Remember, the sine ratio states that sine of B is equal to the opposite over the hypotenuse. And therefore we have sine of 68, because that angle is given. Opposite is h. Hypotenuse is 19.53. Since h is being divided by 19.53, we need to multiply both sides by 19.53. And therefore, we end up with h is equal to 19.53 times the sine of 68, because these 19s cancel. Now, using our calculator, if we take 19.53 and multiply it by sine of 68, we find that the height is approximately equal to 18.1 kilometers. So therefore, the altitude of the balloon is 18.1 kilometers. And there's our second problem. So we needed to use the sine law to help get a side of one of the right triangles, and then use a right triangle to determine the altitude of the weather balloon. Last example. We want to find the value of theta. That's this angle here. The problem is in this triangle, since we don't know if it's a right triangle, so this triangle here, we don't know if it's a right triangle, and we need a third side or another angle in order to find theta, and we don't have those. So we're going to use this first triangle here to help us find this side here. We'll call it x. Because if we have three sides in a triangle, we can then solve this triangle here. So let's start with the first triangle. We have two sides in a contained angle, which means I need to use the cosine law because there is not a known side across a known angle. So let's call this A, B, and C. And notice we have angle A, so I need the A squared formula for the cosine law. So A squared equals B squared plus C squared minus 2BC cosine of angle A. So let's sub in our values. So this is C, so this is B, this is C, and this is A. So we have that x squared is equal to 31 squared plus 23 squared minus 2 times 31 times 23. Cosine of the angle between them, which is 40 degrees. So let's figure out what x squared is equal to, and then what is x equal to. For x squared, we get 397.62. That's approximate. And if we square root that number, we end up with approximately 9.94 centimeters. Now that we have x in our diagram, so we have 19.94 centimeters, we need to use the cosine law once again. But this time we want to find angle theta. So let's label this as BCD. We want to look for angle B, so that means I need to start with B squared for my cosine law. So B squared equals C squared plus D squared minus 2CD cosine of angle B. Notice angle B, side B, because we're looking for angle B, so I need that in the equation. All right, so what do we have? We have D is here, so there's D. There is B, and there is C. So let's use those. So starting with B, that goes on the far left, so that's 28 squared equals C squared is 35 squared plus 19.94 squared, 2 times 35 times 19.94 cosine of angle B. So let's figure these out. So 28 squared. So we get 784 is equal to, remember, we're going to put these two together. So this equals 1,622.6. And then we're going to multiply these three objects together. So this 1,395.8 cosine of B. Remember, we're not going to put these two together because they're not like terms. One has a cosine B, one does not. So we're going to minus the 1622.6 from both sides to get cosine B on its own. So we get negative 838.6 equals negative 1395.8 cosine B. And if we want to get cosine B on its own, we need to divide both sides by 1395.8, or negative 1395.8. Approximately, that cosine B is equal to 0.6008. Remember, I said try to keep as many decimal places as you can when you try to find an angle. And to find an angle, we need to do the cos inverse of 0.6008. So this is angle B, which again is equal theta, the angle we're looking for. And so we end up with an angle of approximately 53.1 degrees. So in our third example here, we needed to use the cosine law twice. So last part, I just want to go over how do you know when to use the cosine law or the sine law. So two sides and an angle opposite one of the sides. So let's draw that picture. Let's say we have two sides, 15 and 17. And we know that the angle opposite one of the sides, let's say here, is 48. Since we have a known side across a known angle, then we use the sine law. If we have two angles on one side, so let's draw that one. So let's say we have this is 48, this is 37, and we have this side here is 21. Well, our 180 rule will get us our last angle. So really we know all the angles once we know two. And that means we're going to have a known side across a known angle. And it could have been any other side as well. So again, we're going to use the sine law. If we want to use the cosine law, we need to have two sides and what's called a contain angle. So let's say we have this side 12, this side 15, and we know that this is 40 degrees. There is not a known side across a known angle. So for this example, we need the cosine law, and the cosine law will help us find that one side. And then we can use the sine law to find the angle and then the 180 rule. And the final scenario, we have all three sides. And in that case, we can then find an angle only using the cosine law.